this lightning demo, I will show you how auto tiering works, look at some common use cases, and then show you a demo where we will be ingesting shopping cart data into our Redis Enterprise database to see how auto tiering works in action. All right, let's dive in. Applications that need real-time processing on large amounts of data have a difficult challenge: balancing performance and cost. Enter auto tiering, a high-performance storage engine for Redis Enterprise that enables large volume datasets beyond the limits of existing RAM by using SSDs or flash memory as main memory. RAM is finite and expensive, so often using a disk-based database for somewhat frequently used data seems like a sensible option, right? Well, not exactly. That data is what we call warm data and should be accessed quickly, and disk-based databases sacrifice that necessary performance. For example, in the gaming sector, when gamers log in irregularly, their profiles consume memory that could be put to better use, such as speeding up gameplay for active users. Auto-tiering can send warm data to SSDs, while keeping the active gamer user profiles in RAM. RAM can be expensive, and offloading less frequently accessed data to SSD can optimize memory usage and reduce costs. What kind of savings can you expect? We've seen up to 70% in infrastructure cost savings compared to deployments that only use RAM. And because auto-tiering efficiently and automatically manages data access patterns, you don't have to waste time manually identifying hot data versus warm data. So how does Redis manage to keep your apps as fast as possible? We have forged a strategic partnership with SpeedDB, layering their innovative key value storage engine on top of Redis. With SpeedDB, Redis Enterprise's speed is enhanced, doubling the throughput and cutting latencies by half while using the same resources. This opens the door to opportunities for a wide range of use cases than ever before. With this improvement, Redis Enterprise's sizing for databases using auto-tiering increased to 10K ops per second per core, compared to 5K. With that, let's take a look at some use cases. Auto-tiering is particularly useful in scenarios that involve segregating data into hot data and warm data. This applies to many use cases, but let's focus on some common examples. First, mobile banking. We all know that nowadays, the closest branch of your bank is handheld, so it's imperative that the most important data returns in real time. Users expect instant access to their current balance and their latest transactions. That data is considered hot data, and it needs to be in RAM. And less frequently, users need additional information, such as a record of an old transaction or a tax document from 2 years ago. It needs to be readily accessible, but real-time speed is less critical. This data set is considered warm data and can be kept in lower-cost SSDs. Another common use case that I've seen is in online retail. Let's consider for a moment online shopping carts. Active carts must perform in real time, so the data needs to be hot and stored in RAM. But I imagine you've probably also received an abandoned cart email that says something like, hey, don't forget about this thing in your cart, come check out, right? I certainly have. And you expected to see your cart still there when you return to the site, right? So retailers can't just throw away the inactive shopping carts, but instead of wasting RAM, they can keep those carts warm in SSDs, and returning customers can quickly finish their purchase after that reminder email. Let's go ahead and see what it's like to set up a new database with auto-tiering. First, we're going to select Create Database in our database configuration screen. We already have Flash toggled on as our default. This gives us the capacity menu on our right. For our shopping carts, we will only need 1 GB of memory, and we'll set the RAM limit at 10% or 100 megabytes. This means that once our database hits 100 megabytes of shopping carts, then the remaining gigabyte total memory will start containing the warm data, which of course can be configured based on either the least frequently used or least recently used eviction policies. And even after setting this percent split between RAM and flash, or hot and warm data, it can be changed in case your requirements change. If you look under the memory limit, you will see some capacity numbers here. It says we have 30.83 gigabytes of RAM and 437.47 gigabytes of flash available. We are building this database off of our already existing cluster that contains 3 nodes. We can create databases and partition RAM and flash based on the total available memory listed here. Lastly, I will name the database and I'll enable search and JSON. All right, name the database and we're good to create. Now that we have our single endpoint here, I'll copy it and run a script here in the background that will load shopping cart data into our Redis Enterprise database. Let's first start off on the metrics tab to see when this load initiates. We'll see an immediate jump in our operations a second, as well as our metrics related to RAM usage. Now let's jump to our configuration tab, where I like to see the indicator on the right that shows our RAM versus flash memory. We are seeing the data coming in, and all of it is first going to be stored in RAM, and then once we hit our 10% limit, the rest will be stored in flash. There we go. Data is now being stored in flash. It's a small thing, but I really like the color differentiation here between RAM and flash is the dark blue and like the lighter blue. It is as simple as that when using auto tiering with Redis Enterprise. As you saw, there isn't any configuration on the CLI, no multi-step process to set up the tiering of data between RAM and SSD, just a simple toggle based on the threshold you need for your requirements. Well, that covers it for our auto tiering lightning demo. We're really excited to release this product that enables performance on what seemed like out of reach large data sets, not to mention reducing significant costs on in-memory storage. If you want to learn more or try it out, check out our auto tiering blog, which goes into detail on how to get started. I hope you've enjoyed this lightning demo, and I'll see you in the next one.